This video is on the equations of constant acceleration, which we commonly call the SUVAT equations. Now this is the second part of P5b, which is this section here at the bottom. So there are 5 SUVAT equations, but you'll notice there are only 4 here. We're going to talk about where the 5th one comes from, that you need to know, and they correspond to those letters that make up the acronym SUVAT. So objectives wise, you need to know the equations and be able to rearrange them. You need to be able to apply them to solve problems, and then you need to show how they link to graphs. So in terms of the module, this is where we're at lesson 4. So the equations then. So the equations connect the displacement, which is the letter S, the initial velocity u, the final velocity v, the acceleration of an object, which must be constant for SUVAT to apply, and the time t. So if the acceleration is non-constant, then SUVAT doesn't apply. Okay, so it's why it's better to, rather than calling them the SUVAT equations, we call them the equations of constant acceleration. So if something is falling under gravity and we assume that there's no air resistance, then usually that acceleration is constant. So they all apply to constant acceleration. The first one is this equation. Final velocity is equal to initial velocity plus acceleration multiplied by time. Now this equation you should recognise a little bit, because the equation for acceleration, which you've done before, is acceleration is v minus u divided by t. So acceleration is the change in time, change in speed divided by time. So by rearranging this equation, you get to this equation. So that's our first SUVAT equation. It just comes from the basic equation for acceleration. Our second one is, again, this should be vaguely familiar to you. This is the equation for speed, which I'm not going to use S for speed, sorry, because that is displacement, which gets a little bit confusing. So speed, or velocity, right, is distance, which I'm going to use S for displacement, divided by time. Obviously remember, displacement is distance in a direction, and velocity is speed in a certain direction. If I rearrange that equation to give me displacement is equal to velocity times time, then that is the same as this equation, but you can see there's an extra little bit. And so this is the equation that we use when we want to know the average speed. So this is the initial velocity plus final velocity, and the reason we divide it by 2 is when I want to work out the average speed, or in this, the average velocity. That's what I do. I add up my numbers and divide by the number that I have. So that's how I work out a mean average. So we use this equation for when we want to know the average. The next equation is the displacement is equal to the initial velocity times time plus half the acceleration multiplied by time squared. And one that's very similar, this is the one that's missing from the specification, is vt minus half at squared. And the last one is v squared is equal to u squared plus 2as. So you should write all these equations down and learn them, commit them to memory. Now there's an important thing for you to recognise here. The reason there are 5 equations is because in the phrase SUVAT there are 5 letters. So this equation does not feature S, it doesn't have displacement. This equation, you'll notice, does not have acceleration. This one does not have final speed. This one does not have initial speed, that's a U, sorry, and this one doesn't have time. So if we have one piece of information missing in a SUVAT question, it doesn't matter, because that basically tells us which equation we are going to use, which will be very important in a minute. One other point to remember is that velocities and accelerations and displacements are all vector quantities, so you have to take into account direction. If you don't, then you will get the wrong answer for some questions. So, just one skill that you need to be able to do is to rearrange these equations. So if I start with one of these slightly harder ones, S is equal to ut plus half at squared. Let's say I want to rearrange this to give me time. So first of all, I would need to do displacement minus initial velocity times time, which will give me half at squared. So remember, always do the opposite. So that's important to recognise, because it's a plus, the opposite of plus is take away. So to go from there to there, I've had to do the opposite. Now here, when it's divided by 2, you can imagine that as being at squared divided by 2. So I want to get rid of the divide by 2, so I times by 2. So I would do 2 times, but it's 2 times all of this. So I'm going to put it in brackets to make it a bit easier. S is equal to minus ut is equal to at squared. And then obviously I've got to get rid of acceleration. So I divide by acceleration, which will get rid of that. So I'm left with t squared. And the last stage, if I just want to get t rather than t squared, is I've got to square root all of this. So I square root the whole thing to s minus ut divided by a. Now that's the rearranged version of that equation to give me t. So you should be able to follow those rearrangement skills, and if you can't, you need to watch the video on rearranging. One thing that often helps though to point out is that if the question makes, say, the initial speed, if they start at rest, they make u equal to 0. If they do that, then this whole bit disappears. So you're left with displacement is equal to half at squared, which is much easier to rearrange. So that is now 2s, so the 2 goes up there, divided by a, that's equal to t squared, and then so to get rid of the squared, you square root, so t is equal to the square root of 2s divided by a. The last thing that you want to be able to do with SUVAT is to be able to use it in a question. So it's very important that whenever you get a question, you underline the key bits of information. So mass is equal to 850 kilograms. We've got a car that's travelling at constant speed. Now constant speed is important because that's the constant speed initially. This car's going to brake in a second. So it's on a level, dry and level road, and the driver is reacting to a problem. Now the car travels 12 meters before the driver applies the brakes. Now if you remember back to P3, this is going to be the driver's thinking distance. So his reaction time is constant, and depending on the speed he's going depends on how far he will travel before he will put his foot on the brake. So that's his thinking distance. He then says that once after he's applied the brakes, the car then stops. So when you see the phrase stops, that's important because that means his final speed is going to be 0. Okay, and we know the braking distance of 18 meters. So calculate the average deceleration of the car when braking. So whenever we get a SUVAT question, we start them always the same way. We write out SUVAT. So S U V A and finally T. So the distance in this question that we've been given is 28 meters because that's his braking distance, okay, or his displacement in a given direction. So that's 28. His initial speed is what the speed he was travelling in before he brakes, so that's going to be 16 meters per second. His final speed is 0. Remember, that comes from the fact that he ends when he stops. The question is asking us to calculate the deceleration, so we need to work that out, and we don't have the time. Now the reason it's important to put this bit as well is that tells me which of my SUVAT equations I'm going to use. So if I just go back for a second, I look for the one that doesn't have time, which is this equation here. So I then write that equation. So v squared is equal to u squared plus 2as. Now in this question, since v is 0, this bit goes to 0, so I'm left with u squared is equal to 2as, because obviously if u squared plus 2as is equal to 0, then these two numbers must be equal to each other. Then I rearrange this to give me acceleration, so u squared divided by 2s is equal to acceleration. I then put my numbers in, so acceleration is going to be equal to 16 squared divided by 2 times 28. And I do that on my calculator and I will get my deceleration, which for this question is 4.57 meters per second. So those numbers can then be used in further equations, so you may want to have a go at this question, which is a nice simple one that follows on from that. You've just calculated the acceleration, you need to know the braking force, so you're going to use F is equal to mass times acceleration. I won't do that one for you, the mass is given to you in the question, it should be nice and easy. But whenever you get a SUVAT question, you must do these steps. So if you look, these are our normal 4 steps. Step 1, write down what the question tells you. Step 2, write the equation. Step 3, rearrange it and put the numbers in. And finally, step 4, work out the answer, the units are given to us here. Okay, so always write out SUVAT whenever you get a question like this, and select the equation based upon the one factor that you don't have. If you have more than one factor that you don't have, then you've got to think about, is it given in the context of the question? So if something stops or if something starts at rest, and if it's falling under gravity, remember that A, we do know then, because acceleration due to gravity is 9.81 meters per second, so that piece of information sometimes is given to us by the fact that something is falling. So remember that as well, please.